Hi guys, this is a quick video on solar and lunar eclipses, Earth and Space number 4. So for Earth and Space learning outcome number 4, what you are learning is that you will be able to develop and use a model of the Earth, Sun and Moon system to describe eclipses of the Sun and the Moon. Just before we get into our lesson, I'd like you to have a look at this YouTube video. What's the difference between a solar and lunar eclipse? Type that into YouTube and you will find this video here. It's only a little over 4 minutes long and it's by this girl here. This is her name is Diana and she has a YouTube channel called Physics Girl. So please give that a watch there now. So now that you've watched that, we're going to dive into eclipses of the sun, or solar eclipses. This is an image of a solar eclipse. This was taken from outer space from the International Space Station. And you can see here that this is our planet Earth. This is the moon, okay, up here. And behind the moon is the sun. So that's what you're seeing around the moon there. Okay, that's sunlight. And on the Earth here, you can see this elongated shadow. So during a solar eclipse, the moon is in between the Earth and the sun, and the shadow of the moon is on the Earth. So let's take a look at what that looks like on a simpler model now. Okay, here's our sun beaming off its sunlight. The sunlight is going directly towards the Earth, but in the case of a solar eclipse, the moon is directly between the sun and the Earth. So the moon casts its shadow onto the Earth. Okay? So that's the solar eclipse. Now, what I want you to have a go at is actually to make a model of a solar eclipse. And this is the success criteria that I want to see in your model. Okay? First of all, the moon should be definitely in between the sun and the Earth. Okay? So just like this picture up here, the moon is in between the sun and the Earth. Okay, next bit here. The moon is smaller than the Earth. Okay, so you want to make sure that for the model that you make, that the moon is smaller than the Earth, like there. The moon is closer to the Earth than the sun, just like we have here. And on your model, can we see the shadow of the Earth? The shadow of the moon on the Earth. Can that be seen? Okay, like we can see the shadow of the moon there. Okay, and then finally, are all of your objects labeled? Have you labeled the sun, the moon, and the Earth? Right then. So here's an example of what your model might look like. Okay, there's loads of different ways of doing it. It doesn't have to be as pretty as this if you haven't got all the paints or anything like that. You can do it out of fruits and vegetables if you want. But as long as you've hit your success criteria, that'd be brilliant. Okay, so that is a solar eclipse. Next, moving on to an eclipse of the moon. So this is a short little video clip here of an eclipse of the moon. And we can see in this case that the moon is in the shadow of the Earth. Okay, so the shadow, this is the Earth shadow going across the moon, but then, so the moon is blocked out. Now at the end there, you can see it kind of turns a red color. We'll talk about that in a minute. Okay, so for our lunar eclipse, the moon is now behind the Earth and is in the shadow of the Earth. So we have got the sun, the Earth, and then the moon. Okay? And the moon is in the shadow of the Earth. Now, going on to why it's red. Okay, this is a little bit extra, but it is interesting. Why does the moon turn red? And sometimes this is called a blood moon. So during a solar eclipse, a lunar eclipse, the moon is in the shadow of the Earth, just like we have here. But if we look over here at the Earth, okay, look up here and down here. On this side of the Earth, it's facing the sun, it's daytime. And on this side of the Earth, it's facing away from the sun, so it's nighttime. And this line here, okay, that line is sunset and sunrise for the entire world. Okay, so and as you know, at sunset and sunrise, the sky is red. So the red light from sunset, all the sunsets in the world and all the sunrises in the world, that red light is cast onto the moon. So that forms the nice red color on the moon. Now, I want you to build a model of a lunar eclipse. Okay, and this is your success criteria again. Okay, this time the Earth is in between the sun and the moon. The moon is going to be smaller than the Earth, just like before, and the moon is closer to the Earth than it is to the sun. And finally, the shadow on the moon can be seen, and all objects are labeled. Okay, so it might look something like this. Now, this is not as good a model because here we can see that the distance between the Earth and the moon, that looks pretty much the same as the sun and the Earth. So I would like the moon to be closer to the Earth and the sun to be further away here. And also, going back to our success criteria, this is not labeled, okay? You want to label it, that is the sun, that is the Earth, that is the moon. Okay, to hit all of your points. Right then, have a go at making those two models. Best of luck, and please be as creative as you wish. Okay, have fun, and talk to you soon.